So 2.2 goes over determining whether you have a relation or you have a special relation that's called a function, finding function values, graphing functions, determining whether a graph is a function with the vertical line test. So a function is a special kind of correspondence between two sets. The first set is called the domain. Okay, and this also refers to your x values. And the second set is called the range, which are your y values. For any member in the domain, there is exactly one member of the range that corresponds to it. This is called a function. Okay, so if we were to look at these points right here, we have, and write them down separately. Okay, we have 8, 2, 0, 17, and -5, 17. The important part, if it is a function, all of these, which are our x values in the domain, have to be different. We don't really care about the y values. It doesn't matter that there's two 17s here, but all the x's have to be different. So this is a function. So I'm just going to write function. Now if we wrote one like this, and we had 1, 2, and we had 3, 4, 5, when we wrote these out, we would have the point 1, 3, we would have the point 1, 4, because we've got 1 going to 4 and a 3, and we would have the point 2, 5. And we would look in this column and we would ask ourselves, are all the x's different? Well, no, because we've got two that are the same. We don't care about the y's in this definition, but the x's all have to be different. So this is not a function. Most functions are described by equations. For example, f of x equals 5x plus 2 describes a function that takes an input x, multiplies it by 5, and then adds 2. To calculate f of 3, take the input 3, multiply it by 5, and then add 2. The result is 17. Therefore, f of 3 is equal to 17. So if we take this basic equation, what we're saying is we've got f of x is equal to 5x plus 2. And if they tell us specifically to calculate f of 3, what they're asking us to do is everywhere we see an x, they're asking us to plug in a 3. So everything else would stay the same except for where we see an x, and they're asking us to let that be a 3. So we've got 5 times 3 plus 2, which gets us 17, which is how they came up with that. So on this problem right here, they're saying f of 0. So they're saying wherever you see an x, you're going to put a 0 there. So on this function, all I'm going to do is write this down exactly like it is, except for wherever I see an x, I'm going to leave that blank. So I saw an x right after the 2, and I saw an x right after the 3. I left those blank because they're telling me to take and put in a 0 there. So if we do this calculation, 3 times 0 squared minus 2 times 0, well, this is 0 and this is 0. We would just end up with 8. Okay, if we do the same thing here, we're going to write down, we're doing the same equation. So wherever I see an x, I'm going to put a blank. But this time, they want me to plug in a -5. So 3 times negative 5 squared minus 2 times negative 5 plus 8. Okay, so that's going to be 75 because negative 5 squared is 25 times 3 is 75. Negative 2 times negative 5 is 10 plus 8. So we're going to have 85 plus 8, which is going to get us 93. Okay, now you can also work this problem on the graphing calculator because f of x is just a fancy way for saying y. So f of x is the same thing as y. So this really could be y equals 3x squared minus 2x plus 8. So let's go to the graphing calculator and look at how we can find what happens when we plug in a 0 and what happens when we plug in a negative 5. So I've gone to my graphing calculator, I've gone to y equals, and I've typed in 3x squared minus 2x plus 8. Now I can go to my table, and remember the things we were looking for were what happens when you plug in a 0 and what happens when you plug in a negative 5. So when we plug in a 0, we get 8, which is, so it would have just told us the answer. And when we plug in a negative 5, we get 93. It gives us the answer when we look at our table. So that's one way you could do this on the calculator. So same thing here. I'm going to work these out the long way first, and then we're going to go back and check our answers. But if I want g of x is equal to 4 minus x squared, well, that means that wherever I see an x in my equation, so for instance right here I see an x, I'm going to put these parentheses because I know I'm supposed to plug something in for it, and then squared. Well, the something I'm supposed to plug in for it is the 0. So 4 minus 0 squared is equal to 0. On this one, I've got 4 minus something squared, and the something that I'm plugging in is negative 1. So negative 1 squared is 1, and 4 minus 1 is 3. This one I'm supposed to do 4 minus something squared. The something is a 1, so I'm plugging that in. So 4 minus 1 squared is going to give me 3. And this one you really can't do in the calculator, but so 4 minus something squared. The something I'm supposed to plug in is 2b. Okay, so I would be left with 4 minus 2b times 2b would be 4, because 2 times 2 is 4. We're squaring it, b squared. Okay, but these other ones, the 0 and the 3 and the 3, I should be able to check those on my calculator by plugging in this formula, 4 minus x squared. So if I go to y equals and clear this one out and do 4 minus x squared, and I do second graph. Okay, so what I was trying to figure out was, okay, what happens when I plug in a 0? I'm supposed to get 0. Well, no, because, sorry about that, 4 minus 0, this should have been 4. I apologize for that, but see, that's one of the good things about being able to go back and check in your work, because obviously 4 minus 0 is not 0, it should be 4, and the calculator, we pulled up this calculator, it checked that for me, and I realized, oh, I made a mistake. So on this one, when we plug in a negative 1, we're supposed to get 3. So we plug in a negative 1, we were supposed to get 3, and we did. When we plug in a 1, we're supposed to also get 3. So let's make sure that one's correct. 1 is also 3, so that's good. Now, it won't check this one for you because we're plugging in variables. So when you plug in the letters, that's one you're not going to be able to do on the calculator. So on the last thing we want to talk about is the vertical line test. And the vertical line test is used to tell if a relation is a function or not. So if we take and we draw a vertical line through a function and it touches the function anywhere more than one time, Okay, so it touches it here, and it touches it here, and it touches it here. So this is not a function. So anywhere I draw a vertical line. Now, some people would say, over here on this circle, they'll say, well, what happens if you draw it over here? You'd only touch it one time. Well, it has to be anywhere on the whole circle. So if I draw it here, I touch it twice. So this is not a function. If you touch it, if you draw a vertical line and it can touch it more than once, it is not a function. So an example of something that is a function might look something like your absolute value function that we've been working on makes a v this way. And if I draw a vertical line, doesn't matter where I draw it, it's only going to touch that blue one time. So this is a function. And that's the end of 2.2.